Hi, I just wanted to kick off, and for newer folks that haven't necessarily worked with us or haven't worked with us in a while, I just want to reiterate, what about the DCSEU? The District of Columbia Sustainable Energy Utility, aka the DCSEU, is set up to help DC residents and businesses use less energy and save money on their bottom line. We've been doing this since 2011 in the district, and we have provided financial incentives as well as the value-added technical assistance and overall informations to tens of thousands of our residents and businesses within the District of Columbia, in an effort to help them, again, save millions of dollars on their energy costs over the tenure that we've been serving the district residency. Our primary focus is also to work on building a brighter economic, environmental, and energy future for the district and its residents. Next slide, please. At this time, I'd like to turn it over to Edward Freeby to talk about refrigeration measures. Kick it off, Eddie.
Thank you, Rick. Thank you. So like I said when I was introducing myself, Edward Freebe. I've worked in the refrigeration space for some time now across various markets, ranging from smaller businesses with smaller walk-ins and package condensing units to some of the larger grocery stores in the district with much bigger rack systems. And I'm super excited to share with you all today some of the measures that we support here at the DCSEU that I feel all types of customers who are involved in any form of refrigeration in the district can take advantage of. Let's go to the next slide, please. So for today's agenda, I will start by talking about the importance of refrigeration, and then I'll go into a list of measures that we support. And then I'll look at a deeper dive into select measures. I've selected 3 for today's presentation. And then we'll look at a couple of real life scenarios and as well as how to work with the DCSEU on any of these. Next slide, please. So yeah, why focus on refrigeration? I found a few stats from NREL, which state that refrigeration makes up about 60% of electricity use in a grocery store, which I would say is a huge slice of the pie in terms of energy consumption, especially within a grocery store. And I can also say that based on a bulk project that I've worked on in the past, it isn't something that is the main focus with grocery stores when it comes to cutting energy costs and saving energy. And the reasons I can think of are because when you work in those kinds of spaces, grocery stores, restaurants, etc., the owners typically want the stores to be as reliable as possible, the systems to be as reliable as possible. And so they wouldn't really want to change stuff if it works. That's the kind of scenario. Also, some of it is not customer facing. So it wouldn't end up in their bottom line, trying to make any upgrades on that front if it's not going to impact the customer at times. The measures that we're going to look at today in today's presentation ensure that the store owners and customers save on energy costs without compromising the integrity of the system and the product that they're selling. The second stat is that refrigeration uses 17% of energy consumption worldwide. So there's a huge market for refrigeration, whether that's food storage, food transportation, medicine storage and transportation with what's been happening lately. All that to say is there's a huge opportunity to cut energy costs, if it's consuming 17% of energy consumption worldwide. Where the DCSU currently comes into the picture is we focus on some of the energy costs with food sales and food storage with grocery stores, restaurants, convenience stores, schools, cafeterias, et cetera. Can we head to the next slide, please? Where I shall look at the measures in detail. We have a bunch of measures, quite a lot here. I'm just going to mention a few off the bat. High efficiency condensing units we support. Efficient evaporator condenser fans we support as well. Fan motor controls, floating suction pressure controls we also support. Heat recovery of the compressor, anti sweat door heater controls, that's a popular one as well. And you also have some of the easier things like LED case lighting, we also support that. You can see from these measures that there are a whole host here that cater to different stages of the refrigeration cycle, as well as different markets as well. On the right there, we have a flyer, a one-pager that I believe you can get off of our website at the end of the presentation that can just give the customer or you contractors a snapshot of some of the stuff we look at, as well as a neat diagram there that shows where that measure is applicable. So now we'll move on to the next slide to go into detail on efficient evaporators, which is one of the measures we support. Many people don't view, last slide, sorry. Many people don't view these as an opportunity, but the fact of the matter is they run 24/7, 365 days a year. They'll always run in most of the time. And they would use typically between 90 and 135 watts per fan motor, depending on what kind of fan motor is in there, if it's a PSC or a shaded pole fan. What we propose is to replace those out with ECM fans, which use much less watts. So you can just multiply that across the number of hours those are running, and it saves a ton of energy. And you would typically have at least 3 in a store. If it's a small convenience store, you would probably have 2 or 3. If it's a larger grocery store, you would probably have multiple walk-in coolers that have a number of these fans in there. Another thing to keep in mind is that by switching to ECM motors, the ECM motors themselves produce less waste heat compared to the older shaded pole or PSC fans. And so that ends up reducing the load on the compressor as well. A common trend in refrigeration is that by improving the efficiency in one side of the refrigeration cycle, you can have compounding effects on other stages of the refrigeration cycle. So you get even more savings. Like you can see in the top left here, Trenton are a popular brand. They're under the United Refrigeration brand. There's also Keep Right. You would also typically have Heatcraft that would sell stuff under Bond, Chandler, or Larking as well. So those are popular efficient evaporator brands. Can we move on to the next slide, please? Right, so how does an evaporator work? It's pretty simple. The bottom line is they aim at removing heat from the walk-in cooler or walk-in freezer. And an evaporator is made up of a fan, which you can see spinning right there, a heat exchanger, and an expansion valve. So the heat exchanger would have the refrigerant running through, and the fan promotes the heat transfer from box air to the refrigerant across the coils. And then the refrigerant absorbs this heat from the box and rejects it outside of the walk-in. So that's the principle down, really. And the expansion valve, its purpose is to modulate the amount of refrigerant that is flowing through the coils to ensure the system runs properly. On the next slide here, you would be able to see a breakdown of an evaporator. So from the left to right, you can see 2 pipes coming in. One is a much smaller pipe, the other one is insulated. The refrigerant would come in through the smaller pipe. It would hit the expansion device, and it would then go across the coils, which in the photo you can see on the top left-ish with those U-looking shapes there. And those go into the evaporator, and on the right, with the black casing there, behind that is the fan motor that we're proposing to be replaced to ECM fan motors. So the fan motor, or rather the fan, would blow across those coils, and then the refrigerant absorbs that heat from the walk-in, and then it escapes out the insulated bigger tube. And you want that insulated because, after it's absorbed that heat from the walk-in, you don't want that heat to then leak back into the walk-in. That kind of reduces the point of, reduces the efficiency, of the system. We can move on to the next slide, where I go through a scenario that we had in the past working with a convenience store that was looking to replace their evap fans. They had 2 evaporator fans in the walk-in freezer, a total of 8 in the walk-in coolers, and they were all shaded pole fans. They also mentioned to us that the boxes were not able to consistently hold the target temperature. That could be a sign of either damaged evaporators, or they could have been old as well, and it was time to replace them. So I did some quick calcs to see what the running costs were, what the savings are, and if it was a good enough project. So the running costs considering that there's a total of 10 fans, was about $1,660, assuming 12 cents per kilowatt hour for the convenience store annually, just to run those fans. And replacing those fans to ECM fans gives us about 12 megawatt hours in savings, which saves them about $1,400 annually. So it's a huge drop in the energy use there. Retrofit costs for replacing fans is about $200 to $400 per fan, depending on the size of the fan or the horsepower of the fan. So even if I assumed, the maximum cost of $400 per fan, the payback for this project is pretty good at 2.77 years, considering these fans have an expected life of about 10 to 15 years. It's a pretty good project. Let's move to the next slide, please. Thank you. So if this is something that interests you or a customer that you're possibly thinking of, or customers that may be in the call, these are some of the talking points that you can go over with the customer, as well as what to do on site if you would want to work with us as well. One advantage of replacing out the older fans for ECM fans is that you would typically have more consistent box temperatures. You would also be able to reduce the maintenance costs, and it creates an opportunity for an integrated system designed to work together. More on that in a couple of slides. And the fourth point there is, at the moment, the DCSEU is offering an enhanced incentive. We're willing to cover a large portion of the material cost of the project, up to about $200 per fan. I think Rick will go into detail later. But if you wanted to work with us, this is the kind of stuff that we'd need. We obviously need to know the number of fans. We also need to have some photos of the model numbers or the nameplates of the existing equipment, and any photos of damaged or ice over coils. Speaking of photos, if you can move to the next slide, here are some photos that we have got in the past. You can see some extensive damage happened to these evaporators. On the left there, you see the ice over coils. On the right was an example of a customer who mentioned that the walk-in was not able to maintain the temperatures that they wanted. And these might seem like problems, but in reality, it happens out in the field, and it can be viewed as opportunities instead. This could be an opportunity for more maintenance with the customer. Maybe a maintenance contract can be established, or some frequent cleaning of the coils as well, or outright replacement. And that's when we would be able to come into the picture to offer any technical assistance or incentive amount, maybe some economic support as well. Let's move on to the next slide. To look at some of the additional measures, because we're talking about evap fans. There are some additional measures that you could also implement into your system, and one of those would be the evaporator fan speed control. Like I mentioned before, evap fans typically run 24/7, 365 days a year, and evap fan controls can be added to reduce either the fan runtime or the speed, depending on the call for cooling or air circulation, while maintaining circulation requirements. So there are a couple of manufacturers that work on this kind of stuff. Trenton has a smart speed evap option where it has two settings, a high and low speed setting. At the low speed, it will be running at 50% fan speed, which would equate to 20% power draw because of the fan curve laws. Heatcraft also has another way of doing it. They go with adjusting the fan runtime. So it's like an on and off fan cycling. And if you're not looking to replace the whole evaporator, you also have 2-speed ECM motor retrofits that are on the market. So if you're just retrofitting just the single fan motors within the evaporator, you can also do that. Looking at that earlier scenario I gave, if the store decided to add fan controls, it would have saved them an extra 2 megawatt hours, which is about $240 annually. And in summary, it originally cost the store $1,660 to run the old fans. ECMs brought that down to about $650. And by adding controls, it takes it even further down to $400 approximately. And that's like a huge 75% drop in energy use, which is really good, honestly. Energy use, energy costs, and that will be beneficial to the customer, considering some of the low paybacks we're seeing. Let's move on to the next slide. Another measure option you could look at are bundled efficient evaporator fans. And I would say this is more of a package system, and it's appropriate if the customer's equipment has run its course and the whole equipment needs to be replaced. The previous two examples, we were looking at fan speed control as well as like a fan retrofit. So if there are other portions of the system that are still not operating as intended, the system has run its course, maybe it's reached its end of life, it might be more appropriate to just replace the whole system. And you can find these on the market. These are bundled evaporator fans, and they would include electronic expansion valves. They already come with ECM fans equipped. They also have the fan motor controls in there and a smart defrost. And you can see it has a display unit at the bottom right of the evaporator where you can tune in the settings depending on the application, walk-in cooler, freezer, whatever type of product you're working with. And this equipment is designed to work better together too. So there's also that benefit. Next slide, please, Kaylin. So that's it for the evap fans, and we're going to move on to door heater controls next. With door heater controls, some people have asked, why are there even door heaters in refrigerated cases if you're trying to keep them cool? And I mean, there's a benefit to having door heaters within those. One of them being it prevents water and mold in the cases. It also ensures longevity of door frames and mullions. If there weren't any door heaters and the doors kept getting wet, you could risk the condensate freezing over, which could cause the seals to rip when a customer opens the door. This also helps with store safety because by heating up the doors, you prevent condensate from dripping onto the floor, which could cause a hazard. And the heat keeps the glass clear for customers. This is what store owners really like about door heaters. You want the customers to be able to see the product from afar, so there's a higher chance of them purchasing something. Another unwanted side effect, though, is that door heaters do cover up poorly maintained cases because the heat hides the effects of bad doors and seals. So door heaters are useful. Next slide, please. Door heaters are useful, but we don't think they need to be running 24/7, which is why we have door heater controls. And door heater controls is a pretty good measure, especially for grocery stores that have a large amount of freezer doors. Typically, you would see they have at least 50 freezer doors. I've seen cases where there are about 150 freezer doors, and by having door heater controls on all of these, it leads to a huge amount of savings. There's electric heat in the door glass, the door frame, as well as the case frame. And with no controls, this costs $220 per door per year. So you can imagine with about 100 doors, it easily racks up to $22,000 to $30,000 just to keep the door heaters running per year. Let's go to the next slide where we look at how we can control those door heaters. So there are three main options that we see typically. There's a scheduling with a time clock. There's cycling the door heaters with a humidistat. And then there's also cycling door heaters with a case-specific dew point sensor. The next slide, we'll look at the savings and costs. Next slide, please. Of these three options. The first one being the time clock, which naturally is the cheapest option amongst the three. There's no sensor involved with this option. It's a typical on-off scenario. It's on a couple of minutes, it's off a couple of minutes. And you could expect something like 35% in energy savings. The second option is the store humidistat, which is the middle of the road option. It's more expensive than the time clock, about 10 to 15K per store. And what happens with the store humidistat is you set it up in, like, say, the mech room or something, and it has a sensor that reads the humidity in the store, and it's wired up to all the cases within the store. So when the humidity is over under a certain threshold, it would cycle on the door heaters or cycle them off. And you could typically expect something like 45% in savings. The most expensive option, definitely the case-by-case dew point. And it's most expensive because it's the most comprehensive, it's more custom. It would literally have sensors on each door of the case within the store. And it's more expensive because of that. But the advantage over the humidistat is that what would typically happen with the store humidistat is it's been set up in such a way that it needs to operate with the worst performing case in mind. So there are certain points in time where the humidistat is telling all the cases to keep the door heaters on, but some of those cases are better performing than others. And so they really didn't need to have their door heaters running on. The case by case dew point option, whilst being more expensive, because it has a sensor for each door, it can easily, instruct each door to turn on or off the heaters. So on average, you end up getting more in savings, but it is more expensive though. So you keep that in mind. Let's go to the next slide, where we look at what to look out for if you're interested in this kind of work. And if you want to work with us on something like this, here's what we would need. The most important thing is the nameplate for each case and frame, which should show the amperage of the door and the frame. This is important for us because we need to know how much energy the door heaters are using. And it can be quite a challenge sometimes to get the photos of these. It can be sometimes in the back of the case or at the very top of the case, at the top of the door, or sometimes at the side. It can create kind of awkward angles to get that photo. And a voltage pen can easily check to see if the doors and frames are running heaters, to see if it's worth your time to look at it or not. Door heater controls, something we've seen in convenience stores, general stores, grocery stores. It's very popular in grocery stores. And it's also super good for freezer doors because those tend to rack up a lot of energy use because of those door heaters. One thing to mention though is to make sure with the customer that the doors or the cases are not going to be replaced soon, because it could be a waste of money if you install door heater controls and then in about 2 years the cases are going to be replaced anyway. Let's look at the next slide, where we see some photos that were taken on site at some stores. You can see on the left there's a lot of ice buildup at the bottom of the case. The middle photo, you can see the glass fogging up there. Something is going on. It seems like the door heaters are either not operating or something. And the photo on the right there came to the conclusion that the seals were bad. So, there needed to be some maintenance on the cases anyway. This is a good opportunity to talk to the customer about door heater controls, because you're going to be working on the case anyway. It's a good idea to talk to the customer about how much energy they can save by installing these. And since you're working on the cases anyway, it might be helpful to kind of lump it into one and work on it at that time. The next slide would show a scenario of a project that I worked on, I believe a year or two ago, with a large grocery store in DC. And they were looking to install an ice sweat heater controls on 138 freezer doors in the store to save on their annual energy use. Doing some quick calcs, looking at the annual energy costs, you have 138 freezer doors running 24/7. That was costing them over $30,000 annually. And we decided on installing the Sweat Miser door heater controller, which is the store humidistat option. And the total cost of the project was $14,260. And after installation, savings came to about 208 megawatt hours, which equates to about $25,000 annually. So this was an amazing payback for the customer, 6-month payback. They already made their money back in a year. It was a really good project, and door heater controls do tend to be a really good project, especially if it's a large store that has a bunch of doors that have all their heaters running 24/7. The payback is almost instant. They're pretty much making money after a year on it. So that's what I have for ice sweat heaters or door heater controls. We're going to move to the last measure on the next slide, which is adding doors to existing open cases. It's a retrofit option to customers with open display cases, and it usually applies to medium temperature cases such as dairy, deli, and beer cases. And energy savings are based on air infiltration reduction from the addition of doors to the open display cases. Yeah, you pretty much save energy because you install a door on that open case, and so it doesn't leak that refrigerated air that is meant for the product. It doesn't leak that refrigerated air out onto the into the aisles. There are also interactive HVAC energy savings by adding doors to open cases. Excess cold air leaking into the aisles no longer has to be treated by the heating system. You would find that, say, during the winter, when the store is trying to heat up to improve comfort for customers. If you have open display cases leaking all that cold air into the aisles, it can be quite uncomfortable for customers. And also it increases the load on whether it's a boiler that's heating up the store, it increases the load. So by adding doors, you also get these HVAC savings because you're reducing the load during the winter for the HVAC system. Let's move on to the next slide, where I have a photo of it before and after they added cases to these open display cases. So this was a deli aisle. They added they added doors to the cases. And I would say it looks pretty good. The product looks very lit up. The product quality is also said to improve. Some customers or store owners have mentioned that they do not like it when they add doors to open cases because it kind of reduces the interactivity between the shoppers and the product. But there have been studies that show that by adding doors, it actually saves money for the store owners. First of all, you do save a lot in energy costs because the energy use of those cases drops significantly. Secondly, the product quality and longevity is also improved. So these are some of the talking points which we'll go over in the next slide. So like I mentioned, by adding doors to existing open cases, you are able to reduce the case loads by 50 to 80%, resulting in significant energy savings. It also helps reduce the load of the compressors during the warmer months. I mentioned that. Also increases aisle comfort, and it provides an opportunity to integrate LED lighting upgrades, which provides better lighting for the products. And then lastly, it also stabilizes case temps, so you get a better product quality and longevity. Let's look at the savings and costs next, which is on the next slide. And typically you would expect something like $350 to $450 per linear foot. The doors are typically 2 foot wide, so something like twice that per door. I've seen cases where it can be about $600 per linear foot, so it can be quite expensive. And it saves about $140 per linear foot per year. That would be 80 in electricity savings and 60 in gas savings. That's from the interactive HVAC savings. So you would typically expect something like a 3-year payback. Let's look at the next slide. So site visits, yes. If you do want to work with us on something like this, I think the first step would be to ask the customer or take note of the condition of the cases. Is it wise to add doors or maybe just replace the cases outright, depending on how old the cases are? Do they look beat up? Is it worth just adding doors or maybe replacing them with newer cases that have doors on them? And we can still support you if you plan on purchasing new cases as well. Especially if you're switching from older cases that are exposed to newer cases with doors, we'll still pay an extra incentive for making that switch from an open case to a closed case. But if it's the right move for the customer, what we would need is to take note of the length of the cases. We also need photos of the nameplates, model numbers to understand the case BTU loads. And is there an opportunity for lighting retrofit as well? That's an important question there. Typically, when you add doors to open cases, usually you would replace any old lighting that is in there, switch those to LEDs as well. So that also adds to the savings. One important thing to mention is you definitely need a certified expert who works on adding doors to cases. The reason being that the case loads drop massively. Like I mentioned before, it's about a 50 to 80% drop. And so it might be necessary to reconfigure the refrigeration system through some case heat load modeling, or there may need to be fan power adjustments to ensure proper airflow within the case now that it has doors on them. And another point to mention is that adding doors are not good for cases that have misters on them, like you would see in the produce section. And also they're usually for cases that are completely horizontal and vertical. So we move on here to the next slide, which is my last slide, which is a scenario of a project we worked on, I think last year as well. It was a grocery store. They were adding 52 feet of doors onto existing open medium temperature cases. A contractor quoted them a cost of $33,000. The savings for the project ended up to be about 34 megawatt hours and 314 MMBTU, which saved the customer about $7,100 annually. And with our help, our incentive really. We managed to reduce that payback to 2.75 years, and the customer was pretty happy. And yeah, it saves energy as well. So we were happy, and all was good. So that's what I have for today. I covered 3 measures in depth. There are a whole lot more that we also support. I would say if there are any measures that were not on our list, we can still have a discussion to go over it to see the energy savings. It could still be a custom project. And I'm going to hand it over to Nicole next to talk about preventive maintenance. Thank you all so much.
Hey, thanks, Eddie. That was great. And to Eddie's point, highlighting the importance of new equipment, equipment upgrades, equipment replacement. It's really sexy, but I'm going to go to the less attractive side, but equally as important, and talk about the preventative maintenance. How do we keep these systems functioning? How do we keep customers' businesses going? And so you all as contractors know exactly how important that is. And so where the DCSEU is now starting to be able to estimate those savings from this work and to develop programs to support both the customers and you as contractors doing this work. So now I'll go and talk about kind of why is this important? And energy savings have always been so core to the mission of our organization, but really we care about the day-to-day operation of this equipment and how it's functioning kind of with respect to the customer's businesses. So how do we keep them going? And preventative maintenance is really the best thing that contractors can do to keep this equipment running smoothly for their customers. And it also gives you an opportunity to build those trusted relationships, and it gives the customer the confidence that their systems are going to be able to preserve their perishable product. Mostly in terms of food and food preservation, but also as we branch into the medical field and talk about vaccines and such. And so some of the measures I'll go into on the next slide, Kaylin. Thank you. This is by no means an exhaustive list, and just some of the opportunities that we see in the stores and the businesses that we're working in. So replacing the door gaskets and seals, we saw that on one of Eddie's slides, to keep the cool air inside the cases that are trying to be refrigerated. That along with air sealing, but as we talk about walk-in coolers and freezers, making sure that the door seals on the walk-ins are good. And if you're seeing customers with cool bots, those are basically those window air conditioners built into the side of a cooler. Air sealing around those pieces of equipment is extremely important. Insulating the suction lines. I have a whole slide about this because of its importance. Coil cleaning, I think that's about the most important thing you can do to keep these systems operating properly. Adding strip curtains. This works in some scenarios. For some customers, the walk-in cooler and freezer doors are open for hours every day. The strip curtains can be a pain for some of the larger customers, but there's also then roll door applications, which are the fast closing roll seal doors that automatically function. Auto door closers, so that behind somebody, if their hands are full walking out, the door will shut automatically behind them to keep that cool air in. And then the second part of the presentation that I'll talk to you about is all about refrigerant leak repair and maintenance. So we'll go into that in a bit. So next slide. We can see how important insulating suction lines are. You know, on the low side and the indoor side of the system, it prevents condensation from dripping and causing water leaks. In the photo that you see on the slide, part of that insulation is missing either from an animal taking it, whether the insulation was never installed properly on those pipes, or whether it got waterlogged from the condensation forming. It's now been removed, and all of that warm air is being absorbed onto the pipe, condensing on it, and then dripping on top of the cooler. In this specific application, there were then icicles forming inside of that walk-in box that were dripping onto product and just causing general degradation to that insulation of the box. On the outdoor side, where the suction lines are being brought to the compressor and then the condenser coil, we want to, that insulation is preventing the pipes from absorbing heat before it's then rejected. And so next I'll talk about some coil cleaning opportunities. And the coil cleaning, this opportunity exists on both the condenser and the evaporator coils, both indoor and outdoor installations. Inside the condensing units are often on top of the walk-in cooler boxes, in attics, in mechanical rooms that are all dirty. There's dust, there's debris. On the exterior mounting side of things, it's just the ambient air with dust and leaves. And if you're in an aquatic environment, you have salt and minerals in the atmosphere. And just by having that buildup on this coil that's supposed to promote heat transfer, it's made with materials that are super conductive. And then you add a dirt blanket to that, it really reduces the efficiency. And there's a statistic that says 1 inch of scale buildup, but this could also apply to dirt or debris, it reduces the overall system efficiency by 30%. And that's because it lowers the capacity of the system to remove that heat. The compressors have to work longer and harder to achieve those temperature set points of the system. And then you just have more pressure drop across that coil as the condenser and evaporator fans are trying to work harder to push the air across. And then this applies both to the HVAC side of things as well as the evaporators right inside of the cooler. The evaporator coils often have ice buildup. And so if the defrost cycles aren't working properly, that's where you can have the inefficiencies. So next slide, I think I still talk about coil cleaning, but from this perspective, it's more in terms of the cleaning aspects and what we can do here. There's a couple different options. A lot of these smaller outlets, they rely on the staff to do this. And it basically can be done with a pressure washer and a wet vac. This is one of the more difficult measures to implement if your staff, especially as we're exiting a year of pandemic where cleaning surfaces and making sure that the safety of the retailer shoppers was more important, the coils probably didn't get cleaned. Kind of shown in the picture is the real Cadillac of the cleaning world. It's a Kaivac case cleaner that basically combines the pressure washer and the wet vac all into one mobile piece of equipment that can do that work for you. So, this is important. It's just not storefront facing, but all of this air is being brought over the produce and the food that we consume. So having dirty coils can lead to food safety issues and fans blowing out. So it's important to address. And now I'll move on to more the refrigerant management side of things. And as we all know, all refrigeration systems leak. It's just a matter of how much. And most of the refrigerants that are being used in our systems today have a really high global warming potential. So there's energy savings, there's greenhouse gas savings associated with keeping the refrigerant in the pipes. There's then the social, economic, and environmental benefits from doing this as well. And so just before we move on to the next slide, the photo on the right shows a Bacharach handheld sniffer. And so I'll describe the equipment in a little bit more detail, but just so that you know what we're talking about. Bacharach's just one of the companies out there that makes equipment for this exact measure. So we can go on to the next slide. And so there's kind of two facets of the leak repair and remediation, and the equipment reliability is really front and center. From a contractor standpoint, you know this, that a low refrigerant charge in a system just means that it has to work that much harder. But coupled with that are also reducing the customer's operation and maintenance costs, and it leads to energy savings throughout the system. So it's important to kind of identify the leaks, fix the leaks in a timely manner, because even a small refrigerant leak over time can really reduce the system operation. You don't have as much problem with refrigerant leaks in larger rack systems because they often have a liquid receiver, which is essentially just a battery backup of refrigerant that can then be used to run the system. But in smaller condensing unit applications or single or double compressor functions, a small refrigerant leak can really lead to reduced efficiency and performance of those systems. And so on the next slide, we'll kind of go to the product quality standpoint and why this is important to the customers. And this food safety piece keeps coming back, and this resilience. And it's so important because this is really the customer's business. It's perishable. And so you as the contractors, you're trying to preserve these products and trying to help the customer sell these products. And so, with the fluctuating temperatures of cases not being able to maintain set point, you have that quality degradation. You have meat that turns brown. You have ice cream that ices up. So having this product quality benefit, it can also then lead to the customer being more marketable, ensuring compliance with local standards and codes, and then that next level of environmental stewardship and pride in the business. And so on the next slide, we'll talk a little bit more about some of the numbers associated with what does this look like? How are we looking to quantify it? And so you'll see some of the estimated savings on this slide. And while it looks small, the project costs are also small. So there's really a net benefit. And when we're talking with our customers, with your customers, and talking about preventative maintenance, like this is how we look to quantify it. And certainly a way that the DCSEU is starting to be able to help you as the contractors and the customers is we can help look at what a preventative maintenance contract looks like. How do you develop it? How do you talk about it? What is it, annual? Is it quarterly? What is best for each individual customer? And we're able to help guide those conversations if that would be helpful to you. And so the chart on the right just shows kind of the efficiency of the system and the running costs of the system as the refrigerant charge is reduced in that system. And as you can see, it's not linear. And it certainly it's not linear with the size of the system either, because you can have catastrophic leaks from smaller systems or larger systems that really throw that off. And we can go on to the next slide, and I'll just show you some cost comparisons. And this is a slide that was taken from the EPA's Green Chill program, which is a voluntary program to help customers, grocery stores reduce their refrigerant leaks. And that $5,000 a year metric in energy savings, that uses a really conservative number for the refrigerant cost per pound. It uses about $6. But as we're talking about R22 Freon, that number can be as high as $30 per pound, and we're just seeing those numbers go up. So this is a really conservative estimate. And if for a typical grocery store with 3,000 pounds of refrigerant, using that 25% leak rate and a GWP value of about 2,500, you're looking at almost 2 million pounds of carbon dioxide that's leaked every year into the atmosphere. So there's a benefit to keeping that refrigerant in the pipes. And then I think I just have one last slide before I pass it on to Rick. Addressing you as the contractors, this is really your area of expertise, and you're the ones in the field. So please let us know how we can best support you in developing programs to support the work that you're doing and support your customers. All right, thanks. That's all for me.
Great, thanks, Nicole and Eddie for your presentations. It was very enlightening, and once again, I thank you. I'd like to go at this point real quickly over next steps. What can you do to engage with us, and kind of a couple key highlights I'd like to bring to everyone's attention. As Eddie mentioned, I'm going to cover a little bit more about our refrigeration campaign and some of the incentives that are available to your customers. For a limited time, we are offering to cover up to 100% of the material costs for qualifying refrigeration equipment. Currently, the two measures that we will cover up to 100% of the material cost on a limited basis, first come, first serve, are going to be around the ECMs, the electronically communicated motors. We will pay up to $200 per ECM installed. As you heard earlier, Eddie mentioning that typically these measures run between $200 and $400 installed. So it covers a huge portion of that material cost to the overall cost. Door heater controls, we will pay up to $1,000 for door heater controls with at least 2 doors minimum on controls for freezers 8 doors for refrigerated cases is the minimum criteria to qualify for that super enhanced incentive. Next slide, please. In addition to those two measures, and the nature of it being a limited time offering, as I said, first come, first serve, here's a snapshot of rebates available prescriptively in the refrigeration realm that's available to you to sell to your customers to help offset the installation costs. Everything from reach-in refrigerators, freezers, ice machines we didn't talk much about, and the controls specifically in a more detailed breakout. Some of the measures were discussed in depth. Some of the other ones, certainly feel free to reach out if you have any questions about any of these measures. Next slide, please. As you can tell, I had the engineers and the account managers introduce themselves, and what I wanted to do was set the pathway to the different ways you can all work with us in general. As I mentioned earlier in the last 2 slides, we have a self-service type approach where measures are prescriptive in nature. And feel free to take advantage of that on a transactional basis. But we also want to enhance and make aware that the engineering and account management team stands ready to support you on the custom services that you may require. The more in-depth analysis, the true value add engineering support and validation certainly will go a long way to help your customer and you as a contractor do the most efficient options where available. Next slide, please. That no technical cost support really covers everything from helping you all identify the opportunities, as Eddie mentioned, and Nicole. They're great subject matter experts, for instance, of what they've seen in the field. They walk the walk. They see what customers are experiencing and what our contracting base sees on a regular basis, in an anticipation with our account management team and helping find solutions and help reaffirm any project analysis that would help support the investment in that technology. Next slide, please. I'd also like to take a brief moment to go over other contracting opportunities that are available to you outside of the refrigeration. We do have a couple other efforts that we would like to highlight at this time, and some possible opportunities for folks on this call. Next slide. We have relaunched our capacity building training program. We've actually got a better named acronym now. It's called Train Green. It's a branded name for the Sustainable Energy Infrastructure and Capacity Building Pipeline Program, a little bit easier to say per se. The design around this program is really to help our local businesses and our local contracting base enhance skills around energy efficiency and renewable energy in the design, construction, and maintenance of the various technologies that we all are involved with. These trainings are currently at no cost, and most of them come with credentialing and/or certifications. I want to put the plug in that in order of preference for folks, if you're a district CBE or a CBE eligible firm, you are first priority. Folks that are district residents working outside of the district for firms located in the DMV area are certainly of a priority to us. And finally, anyone that's in a business, individuals and businesses in the greater DMV area. So think of the Beltway Loop per se, and you're doing business in the District of Columbia. You're also tiered as an option to be able to be eligible. You certainly can learn more at the link provided in this slide, and I believe Kaylin will be sharing the slide later with you all today. I would also encourage you that take a look at the pre-registrations. We are taking pre-registrations at this time for the courses that we are offering, and it would be advantageous to sign up. Once again, it's first come, first served. So once the courses get fulfilled and it's fully subscribed, we'll have to defer till to the next round of training for folks. Folks that are eligible, you can see on the right hand side, pretty much anything from architects to manufacturers, distributors, our contracting base, property, building owners, and facility folks certainly should take advantage of the no cost trainings. Next slide. Finally, if you have not already taken the chance and opportunity to sign up for updates, please utilize this link, sign up as an individual and for your firm to receive our Trade Ally newsletter, our quarterly newsletter, where we provide updates to any activities that we are planning on doing, offerings and such, as well as any future training sessions that you might be interested in. We'll have that in there as well.